Good evening again, and let's start this webinar. As you know, this is an AWS certification webinar, and we have been conducting this regularly. This is to give you some tips on how to deal with some of the AWS services when you're taking up the certification exam. We have already done the webinars for EC2 and S3, and today we will be dealing with databases. So in databases, we will be talking about DynamoDB, we're talking about RDS, we'll be talking about Elastic Cache, and we will talk about RedShift and when to use which of these. So that's our idea today. So let me go ahead, share my screen with you and show you the different points that you need to remember in each one of these services. Just give me a minute, and as usual, I'll be sharing the screen with you. And here are the slides. So we are going to talk about various databases. And before we go there, like I say every time, let me clarify what this webinar is going to do. The webinar is not to explain every service to you. We assume that you know about the service. This series will talk about important points of each service. We will discuss what could be the probable questions that may come up during the exam. And if you want to learn about AWS in detail and you're not really into the subject yet, you can always visit CloudSiksha Academy if you want to learn more about AWS. That's academy.cloudsiksha.com. You will see that in the description part of this video as well. So let's start with the database services that Amazon provides, and we'll talk about 4 of them today. The relational database service, the NoSQL database service, which is the DynamoDB, the in-memory database service, Elastic Cache, and the data warehousing service known as RedShift. So let's start with RDS, or relational database service. Now, relational database service, as you would know, is a service which is something which is set up for you. A database is set up for you by Amazon. Now, Amazon sets up a database. Which database? Well, it sets up Amazon's Aurora database or MySQL database, Postgres SQL, MariaDB, Oracle, or Microsoft SQL Server. So what additional features does RDS give? Again, they take daily backups for you. They do patch upgrades. And it's very easy to scale the database in terms of its compute power or in terms of its storage whenever you need. All you need is to change the parameters, and you need to click a button and you can have the scaling happen. Normally, when you scale in your own data center, you will find that you have to do a lot more things when you have to scale. We now come to the backup and restore part. The first thing is that backups are of 2 types. One is the automated backup. The other is the user-initiated backup. The automated backup as well as the user-initiated backup are both snapshots. So they take the snapshot of the database. Where do they store these snapshots? They store these snapshots in S3. Therefore, you will have a high level of durability of your snapshots, or your backup is very highly durable. In the case of automated backup, you can ask for a retention period, and the retention period can be up to 35 days, starting from 1 day. If you say 0 days retention period, it basically means you don't want a backup. If you don't have a backup, you cannot obviously restore if there is any problem with your database. Now, in the case of an user-initiated backup or a user-initiated snapshot, you can take it at any point in time. The daily backups are generally taken at a defined point in time every day. It's automatically taken at 12 o'clock in the night. If you don't reset that, you can set it at any hour of the day that you want, and it will be taken at that particular hour. Whereas in the user-initiated snapshot, you can take any time you want. You just go and ask for a snapshot. The snapshot will be taken. And the snapshot will be retained till the user deletes it. Now you have to go and delete the snapshot. In fact, if you delete your database, that is, if you delete your RDS instance, the automated backups will all get deleted automatically, but not the snapshot that you took. So your snapshot would still remain there. So you need to understand this. So when you delete an instance, all automated snapshots get deleted, but the user-initiated snapshots will not get deleted. Next comes the restore. Now, restore can be of two types. One, you can restore a snapshot. So you can point to a snapshot and ask that snapshot to be restored. That will be restored. Or you can restore up to a point in time. So you can see that there is a point in time restore. The point in time restore basically restores to till a certain point in time, till the time where they have taken care to back up all your writes. So when it is restored to a point in time, basically the last snapshot will first be restored, and after that, all that you have written, every write will again be replayed over that snapshot to get to that point in time. A very important thing for you to understand is that restore will not overwrite your database on the instance. So if you are running an instance, a database instance, a restore will not overwrite that instance, that will not overwrite on that instance. Rather, it creates a new instance. In other words, you will now get a new DNS name because you have a new instance. So restore always creates a new instance. It can't overwrite the database of the instance that you are running now. In case of things like MySQL and all that, if you want to migrate, you can do a dump of MySQL and upload it into S3, and from S3 you will be able to restore it back. So if you are looking at the new console of RDS, you will see for MySQL there is a restore from S3 button. So restore from S3 button basically will restore the database of yours from S3. That is if you want to migrate from one place to the other. Other two important things that are done by RDS are multi-availability zone deployment and read replicas. Let's have a look at each one of them. Multi-availability zone deployment basically will set up two instances, two database instances, each running in a different availability zone. But this is a region-specific service. That means it cannot span regions. You can't have one database running in one region and the replica in another region. It is only within the region and it's in a different availability zone. So it can ensure that if an availability zone fails, you'll be able to switch over. Now this replica is a synchronous replica. Basically, multi-availability zone ensures there is a synchronous replication going on between instance in one availability zone with an instance in another availability zone. And the failover is automatic. Now, what does this mean? It means that the primary, that's the one which is the read-write part of this replica, if that goes down, then automatically users are connected to the secondary, that's the replicated, they will be connected to the replicated instance. The users per se will not have to take any actions from their side. The DNS name remains the same. This is very, very critical. The DNS name does not change, and the users don't need to try and connect to a different DNS name and so on. They will connect to the same DNS name. They will not change anything. But internally, using Route 53, Amazon will ensure that the same DNS name now reaches a different instance. Now, this overall thing of multi-availability zone is given to you free of cost. That is, there is no charge for the failover that Amazon takes care of. There is no charge for the replication that Amazon takes care of. Of course, you will be paying for two different instances that are running at two availability zones. But overall, you are not going to pay for any of these other parts, that is the automatic failover or the replication. Another important thing that you need to understand here, and which may appear in the exam, is that when you're doing replication, you have two instances. The one instance called the primary, the other is called a secondary. The primary where we write and read. The secondary where we just write from the primary. It's a destination or a target for replication. That is generally not used to reading, and the users don't even know the existence of secondary. Now, when you're taking backups normally, what happens is the backup is a read intensive process. So when you take backups of an instance, that is when you're taking the snapshot of the instance, during that time, you would see some latency. The user will witness certain latency because of the fact that there is another process which is running, which is reading from the same database, and that would slow down things. Now, if you want to avoid this, you can take the backups and snapshots from the secondary. That is allowed. So you can take the backups and snapshots from the secondary. The other thing is, if you want to test the failover, you can always reboot the primary. When you reboot the primary, you will see that the secondary has taken over, and then you will see that the availability zone of the instance has changed. This is one way of checking if there is indeed a failover that is happening from the primary to secondary. Now, after we look at the multi-availability zone deployment, we'll look at read replica. But before going there, let's again emphasize on one thing, that a multi-availability zone deployment is a high availability solution. It is not a solution to scale. That is, if there is too much load you want to scale, That is not the solution. Of course, we do try to keep the latency low by taking backups from the secondary, but that is not really scaling. We are not sending requests to different databases here. All requests come to the primary for writing. And therefore, this is a high availability solution and not a scaling solution. So next, let us go and look at the read replica. The read replica is a scale out solution. Now, what is a scale out solution? Scale out is the one where you use the more number of instances to handle the load. If you have an application which is read intensive, or if there is a need for you to provide a replica for reading, then a read replica is a good solution. So let me describe something like this. Let's assume that you are a e-commerce site and you have a production database, and your marketing department wants to run a data analysis program on the production database because it wants to find out certain trends. Now, if you let them do that, then you will experience a huge amount of latency, because the data analysis programs, if you run, they will be read intensive, and that will have an impact on your users. So users will see the performance as degraded. We don't want that to happen. So what you can do in these cases, you can make a replica of the database. This replica is a read-only replica, and a new instance is created, and this instance is in asynchronous replication with the primary read-write instance. Now, the asynchronous replication basically means that the primary and secondary are not always in sync. There could be a certain, what is known as a replication lag. So when you create a read replica, you will get a new database altogether. A replica database is to be treated as a new database, but it's a read-only database. What do you mean by treating it as a new database as opposed to the multi-availability zone deployment? Here, the new database or new instance is that you will get a different DNS name for this replica. Now, if you see in the multi-availability zone, you don't get a different DNS name for the secondary. As I said, the user doesn't even know the existence of the secondary. Whereas in read replica, you make a replica and you may give that replica's DNS name to others to connect. For example, in the earlier case, we could make a read replica and give it to the marketing folks to connect. You can tell the marketing folks that they should connect on the read replica. So they would use the read replica, and the production people would continue using the production database. In this way, now you have scaled up. So you have split the load between two different instances, the production instance still serving the production case, and the read replica serving the data analysis case. The replicas can be done across regions, unlike the multi-availability zone deployment. They are done across regions. And we have to understand again that read replica is a scaling solution or a scale out solution. It is not a high availability solution, because there is no single DNS name here. Your DNS names are different. If one fails, you need to connect to other. The user will need to make changes to connect to that. And again, the secondary is only a read only. Of course, if you want the secondary to become primary, you can promote the secondary. There's something called promoting the secondary. You can promote the secondary. When you promote the secondary becomes read-write, but the asynchronous replication will be cut now. There will be no more replication. So the secondary will become an independent database, which can be read and to which you can write. So you remember these things when it comes to the exam. Multi-availability zone is an HA solution. It's not a scaling solution, while read replica is not an HA solution, it's a scale-out solution. For example, I've seen a lot of questions on the web which ask about how do you ensure high availability of infrastructure. They may tell you that on a web servers, you keep a load balancer and the web servers in 2 different regions, and then you come to the database, they would say keep read replicas as one of the answers. Now that's not the answer, because read replica cannot be an HA solution. So the answer would be a multi-availability zone solution whenever they talk about ensuring redundancy in your infrastructure, that no single point of failure cases. So the questions will come like that, in the sense that they would say, we want to ensure that the infrastructure does not have a single point of failure. How would you do that? And when they come to database, they may give you an option of having a multi-availability zone, having elastic cache, having read replicas and all. There you know that it has to be a multi-availability zone deployment if you want a high availability one. Similarly, there would be questions where they may be asking about users reading a lot and that your application is read intensive, and would be asking how you would take care of the reads that come. In that case, whenever they say put your database into multi-availability zone deployment, then you know that it's not the right answer, because multi-availability zone deployment will not give you scaling. So there, the right answer is, of course, you want to put up a read replica. Okay. Another important thing you have to remember is that read replicas are not available for all the databases. They are only available for Aurora, MySQL, Postgres, and MariaDB. That is Oracle and Microsoft SQL. If you use, you would not be able to use the read replicas from Amazon. Keep that in mind. So that was about RDS. Some of the important parts of RDS. Of course, you will need to look at the storage in RDS, which would be around, in terms of what do you call? You have general purpose SSDs, you have provisioned IOPS, you have magnetic disks, all that which are generally there, and you know which disk to be used for what. If you had seen my earlier video on storage last time. So keep those in mind. That's how we would deal with the storage. Now after RDS, let us go to DynamoDB. A DynamoDB is a NoSQL database. Some important things to remember. One, it's a key value store plus a key document store. It supports both key value and key document. There is no limit to the size of the database. In RDS, you have to specify the size of the disk that you want. And the size of the database that you can deal with depends on which database you're dealing with. Like Aurora deals with a larger disk size, and MySQL would deal with a smaller one. Like some things can go to 32 terabytes, some things can go to 16 terabytes, and so on. Whereas in DynamoDB, there is absolutely no limit. You can think of DynamoDB like S3, right? You just keep on writing your data, and it sort of expands and expands and expands to fill up the available space. I mean, it just keeps expanding, repartitioning, doing everything. So what they do is that all the data that you store, that is automatically replicated within a region. It's again a region specific service. So if you have a DynamoDB, you have to specify which region you are using in, and it will make copies of your data within that region. If you need, you can set up a replication from one region to other. And nowadays, they've also allowed you to do backup of the DynamoDB. You can back up your DynamoDB. You can set a backup for the DynamoDB. Here, as I said, you don't have a limit to the database size. You can store as much as you want. Added to it, you can also set the read and write capacity for every table that you create. Read-write capacity is how much IOs you can, how many reads you can have per second and how many writes you can have per second. So you set them up when you create a table, and later on, if you need, you can change them. So that is very important for you because that can dictate what sort of speeds you get, what sort of response time you get from DynamoDB. There is a limit to it. I think that they allow you to do something like 10,000 as the maximum limit. But if you need more, you can ask Amazon and they may set it up for you to give you more than 10,000 read or write capacity. The main things about DynamoDB is that in DynamoDB, you have a partition key. Now, this is like a primary index. You have two ways of defining the primary index. One is a simple partition key. This partition key or hash key as it's called, if it is defined, then every item that you put into the table needs to have this particular value. The item must have this key. For example, if you are pushing in a lot of product details into the table, and if your partition key is called as a product ID, then every item that you write to the table must have a product ID in it. So product ID, and the numbers may change for the ID, but every key must have the product ID. You can also have product key and a sort key. Now in this, or sorry, the partition key and a sort key. If you have a partition key and a sort key, the partition key need not be unique or the sort key need not be unique, but their combination has to be unique. So in the first case, if it's partition key, it has to be unique for every item that you put in. In the case of a partition key and a sort key, it has to be, combination has to be unique. For example, you may be storing data about all the books you have in your library, and the partition key could be the name of the author. The sort key could be title of the book. So the author plus the title of the book has to be unique. The author may reappear multiple times. Now, DynamoDB also supports what is known as secondary index. So whenever you try to retrieve objects from, when you retrieve data from DynamoDB table, you have to get them using the partition key or the partition and sort key. But assume that you need something else also sometimes to get your data. For example, you may want to get data of all books based on the price of a book. So you want to get based on the price of a book, or you may want to get using publisher. But the publisher, for example, is neither your partition key nor the sort key. Then you can ask for a secondary index. So the secondary index is of two types, the global secondary index and local secondary index. A global secondary index will have the partition key and sort key different from that of the primary index. So it will, both the partition key and sort key will differ, Whereas in the local secondary index, the sort key will differ, the partition key would be the same. And both of them, you can have around 5 of them. So for each of this, there's a separate table created so that whenever you want to access data using the secondary index, you get the data fast. Now, when you want to deal with the tables in terms of reads and writes, and you want to give what read capacity you want and what write capacity you want, in that case, you need to understand that reads will have two different types of consistency. One known as the read after write consistency or the strong consistency, and the other is known as the eventual consistency. Now, read after write consistency, if you are asking for 1 read per second for as your capacity, if you are saying, let's say 100 reads per second for read after write consistency, with the same thing, you could actually do 200 reads of eventual consistency. So they are like 1:2. So you can say that you could do 200 reads eventual consistent read per second, or you can do 100 strong consistent reads per second. So when you are doing the sizing, you have to take this into account. Now, the DynamoDB also has what is known as an auto scaling available. Now, what is this auto scaling capacity? Now, it's not about the storage, because we know the storage is infinite. You can store whatever you want. Auto scaling is about the read and write capacity. Now, you are charged based on how many reads and how many writes you want to do. So if you say I need 100 reads per second, 100 writes per second, you're charged a certain amount. Suppose you say I want 1,000 reads and 1,000 writes, you're charged a different but a higher amount. You don't know how your application is going to behave and when there will be too many writes, when you will be too many reads. In which case, what will happen is you will either oversize or over provision it or under provision it. So both are obviously a problem. So we don't want our performance to suffer. At the same time, we don't want to be paying too much of money without actually using the feature. So for that, to take care of that, they have now introduced auto scaling. Auto scaling means you can, like in the case of an auto scaling of instances, here you can auto scale the read and write capacity. So depending on how many reads and writes are happening, the number of reads per second, number of writes per second, those values will automatically be changed by DynamoDB itself. And if you want much more speed now, there is a DynamoDB caching also available. These are new introductions which happened towards the end of last year. So that's about DynamoDB. Keep that in mind about partition key, about the secondary index, auto scaling capacity, and so on. The other database is the in-memory database. It's called as Elastic Cache. The in-memory database that Amazon supports is Memcached and Redis compliant. That means you can use Memcached or Redis programs to write to the memory, read from the memory. Redis, for example, is a key value pair database. The overall setup of Elastic Cache is done by Amazon. So you can ask for multiple nodes. The multiple nodes will be set up, and even in Elastic Cache, you have read replicas. You can back up the data, etc., etc. A lot of things are there. But from an examination point of view, the main thing that usually comes up when it concerns Elastic Cache is in terms of its being very useful for reading. So if you want sub-millisecond response times, so you'll get a question this way that the application you have is read intensive and people are seeing bottlenecks, what would you do? And give you multiple options like do a multi-AC deployment of your database, do make it DynamoDB, something. Basically, there you will see that there is an option for either read replica or to use Elastic Cache. Both of them will be the right answers because Elastic Cache will improve your reading speed. So if you have Elastic Cache, you can improve the speed of reading, and that's because it buffers your data and it gives everything from in memory, and therefore it is much faster. So whenever you see such read-based questions, you know that Elastic Cache is going to be one of the answers. So that's a level that I generally see questions coming from Elastic Cache. They don't go too deeper into finding out other things. Just remember this supports Memcached and Redis. The other type of database that is supported is the database for doing data warehousing. So Amazon has this data warehousing solution called as RedShift. Now, this RedShift stores petabytes of data, and it has multiple nodes, and it's a cluster sort of a thing, and you run your data warehousing, your database in that cluster, and it is called as a columnar database. A columnar database is very good when you do reading of data. In data analysis, columnar databases are very useful and they give good performance. So Redshift is a columnar database. It allows you to connect via JDBC and ODBC options. I mean, both options are available. You can connect, use your favorite BI tools, that is the business intelligence tools, use the SQL programming and analyze the data that is there. So the setting up this cluster and populating the cluster and then allowing you to program the cluster, all this happens, and in this the cluster setup, the cluster maintenance, everything is done by Amazon. So basically you can load data to Redshift in multiple ways. One of them is you can load it directly from something like Kinesis, or you can load it from S3 and so on and so forth. But the idea is Redshift is for data warehousing. So it is for storing petabytes of data and ensuring that this data can be analyzed, and so running for data analysis on this data. So finally, let's have a quick summary of which database to use where. So we are talking about databases. We want to know where to use which database. Of course, there's a relational database exists whenever there is a need for it. I mean, if your program has been written for an RDBMS, then I don't think you have any choice. You need to use the relational database service, that's the RDS. So that way you would know if your program is already on RDBMS, and there are multiple programs which use RDBMS, so you can use that. Secondly, whenever you see a question where they say that the space requirement is not known, that you have to store large amount of data, you have to store indexed data and a large amount of data, and each data item may have a different values. I mean, some may have 4 values, some may have 5 or 6 values. When these sort of values change and the space requirement is not known, and they're looking at very fast storage retrieval type of thing, then you look at a NoSQL database. In those cases, you can use a DynamoDB, where you are talking about queries which are not very complex, right? NoSQL, well, there's always a very major debate on which is faster, which is slower, and all. We'll not get into that, but Whenever you're talking about a simple queries, like just queries on a partition key, a query on partition sort key type of thing, but not looking at joins and other things which are well known in the RDBMS world, but a simple query type of thing. Suppose you have a leaderboard, you want to pick up who's the leader, you want to pick up based on products, based on product ID type of things, simple things. Then DynamoDB would be a very good database to store the data. But as I said earlier, when you want to read things faster, you want to improve your reading speed to sub-milliseconds, then we would look at using Elastic Cache with either Redis or Memcached programming. Then if you have petabytes of data to analyze, you want a data warehousing solution, you are looking at using something like Redshift. So that's sort of an idea of what databases to be used where. So most of the time, your questions are going to be around this, in the sense that, you know, they ask you, okay, this is my requirement, which database is better to use, what is to be used, type of thing. Then you know what needs to be used. And as I said, in RDBMS, you have other things like high availability solution or multi-availability zone and scale out solution on read replicas, whereas you don't need to worry about high availability of DynamoDB. It's already own replication of your data. And at all, if you're talking about disaster recovery, or you can always do a replication of your table to another region if you want. So these are some of the important points that I wanted to talk to you about as far as the databases are concerned. Of course, within the short time, I couldn't probably cover every single inch of the databases. What I covered is some of the key points that you need to look at. Of course, you have to read more and get into some of the nitty-gritty details about each of these services, because sometimes you get questions which are more detail-oriented than the concept-oriented, right? But they are lesser in number. Once you understand the concept, right, a lot of these scenario-based questions you will be able to answer. So that's the idea of mine, was to give you the concepts.